Welcome to another exciting educational video brought to you by Up Vision Concepts Academy. So again, today we'll be looking at IGCSE Physics, and the topic for our discussion is acceleration and the equation of motion. So by way of objectives, by the end of the class, you should be able to define acceleration and describe what positive and negative acceleration means. Again, secondly, we'll calculate acceleration using the correct formula. Number 3, understand and apply the 4 equations of uniformly accelerated motion. Number 4, solve problems involving objectives or objects starting from rest, coming to rest, or moving with a constant acceleration. And finally, interpret and calculate acceleration from velocity time graph. So sit tight. It promises to be another exciting series. If you are yet to subscribe to our channel, kindly subscribe. Just hit the subscribe button down below this video and get into our community. Also share so that some other people can be part of what we are doing here. All right, so we dive in. Okay, so first off, what is acceleration? Acceleration measures how quickly an object changes velocity. So by way of formula, A is equals to change in velocity over change in time or time taking. Change in velocity over time taking. Okay, so I have V minus U over T. Okay, so I will define my parameters where A is acceleration. Acceleration is measured in meter per second square. Change in velocity is change in velocity. That's this one. Change in velocity. V is final velocity in meter per second. And U is initial velocity. Initial velocity, meter per second as well. And T is time taking. So these are the parameters in this equation. So it measures how quickly velocity of an object changes. So if A is positive, if after computing this, if A is positive, what does it mean? What does it mean? The object is speeding up. The object is speeding up. And if A is negative, that is, if you compute this and this, the ratio of this, if it gives you a negative value, the object is slowing down. The object is slowing down. So this particular one is known as deceleration. Deceleration. So deceleration is actually negative slope or negative acceleration. So a velocity time graph shows the relationship between the velocity and the time taking. So it is a graph that shows the relationship between velocity on the y-axis, meter per second, and time on the x-axis. That is why we are calling it velocity time, VT, velocity time graph. So the gradient of the velocity time graph is acceleration. So if I start from somewhere maybe like 0 and I go up like this, that is, as the velocity is changing, time is also changing. You understand? Of course, as time goes on, velocity will be changing, right? So the slope of this velocity time graph is known as acceleration. Acceleration. Of course, this is consistent with the fact that the ratio between velocity and time will give me acceleration. So if I do something like this and get the change of this and this, I get acceleration. So the slope of that velocity and time graph relationship, time relationship, is acceleration. But if I have many other components of the movement, say at the point, maybe when you get to this point, and this point is known as the maximum velocity, understand? It started having a constant velocity as time changes. Velocity does not change as time changes. So you see there's this T1 here, and there's T2 here. T2 actually is maybe the point where the movement started going down. Understand? And T3 is where it ended. Okay, I'm trying to describe, what's different components of movement. So I can start from rest, that's 0 point, and I move up to this point where I have the maximum velocity, and the slope of this graph is known as acceleration. Okay, so this place I have a constant acceleration. Acceleration at this point is 0, and at this point is negative acceleration. That is deceleration. This is deceleration. Deceleration. All right. So I have acceleration here, and the constant acceleration here. Okay, so I have different times where you attain the first T1 here, you attain maximum velocity, and the T1 to T2 is where you have a constant acceleration, and the T2 to T3 is where deceleration happens. Now the area under this graph, that I will shade this point like this. I will shade all this area like this. This shaded area is known as displacement. So again, I will say gradients or slope of the VT graph is acceleration, and area under the graph is displacement. So sometimes you are asked to calculate displacement from a VT graph, that is from a velocity time graph. You just know that you are calculating area. Okay, so they might specify the components of that movement, whether it is from between when you get to final they might specify the components of the movement question, whether it is when it got to final, the highest velocity, at the time it takes to find acceleration at that point, or to find the area of that point, the displacement of that point. So in that case, you are finding the area of this triangle like this. You understand? If we are told to find the displacement where T1 happened, and T1 is actually where you have maximum velocity. So just find the area. If it's to find the displacement at T2, it means that I am going to be finding the area covered by these parts like this. You understand? Maybe I will name it O, A, B, then this is C, this is D, this is E. You can just get the question very well and know the point where you want you to calculate the displacement and find the area of that shape. So that will give you displacement. So next off is the equation of motion, or SUVAT. SUVAT. Actually, it's an acronym that stands for the different parameters that we are looking for. But I will just, before I disclose what this SUVAT means one by one, I will start by saying that for uniform constant acceleration, these equations link displacement, velocity, acceleration, and time. So if I have the first one is V is equals to U plus AT, right? So this is the first one. Then second equation, S is equals to UT plus half AT square. Third equation is V square is equals to U square plus 2AS. And the fourth equation here is S again equals to U plus V over 2 then times T. Okay, so let's note all this. But where S is displacement in meters, U is initial velocity. This is in meter per second, right? V is final velocity. final velocity. Again, meter per seconds. A is acceleration, and this one is in meter per second square. And finally, T is time. This one is seconds. All right, so this is the SUVAT. So this is how these parameters are related in this equation. Master these 4 equations very well, because you are going to be using them in IGCSE Physics. You'll be asked some questions. Sometimes one of these will be missing. So if you have in your question, you have this and this and this and this mentioned. If one is missing, you are using this formula, and so on. Sometimes you might need to have a mixture of formulas. Like I said in one of my videos, I said physics has to do with using skills from mathematics. If you know how to use mathematical skills, then physics will not be a problem. All you need to do for physics is to just understand principles, then every other thing is formulas, calculations, and apply mathematical concepts. So there are times in this study where you will be using simultaneous equations to solve and get the answers, substitution methods, and just to understand the question and know what formula you are going to be using. All right, so we'll go through the worked example on acceleration. Okay, so how on the board says a car increased its velocity from 10 meters per second to 25 meters per second in 5 seconds. Find its acceleration. So acceleration A is giving us change in velocity over time taken, where V is final velocity, U is initial velocity, and T is time taken, right? Okay, so we're going to plug in all this into this equation. Acceleration is what we're looking for. It said the car increases from. So where it's starting from is initial velocity. This is initial velocity. So A is equals to, final velocity is 25 meters per second. 25 minus 10 over T, 5, right? Okay, so compute the numerator first. 25 minus 10 will give me 15 over 5. So finally, 15 divided by 5 will give me 3. So acceleration is 3 meters per second square. Okay, so this is velocity, meter per second, and this is seconds. All right, so meter per second square. That's the answer. You can actually, it's good practice to do it as like this, 3.0 meter per second, just for optics, so just to know, to do it to 1 decimal point, right? Okay, so on the board, a car starts from rest and accelerates uniformly at 2 meters per second for 8 seconds. Find its final velocity and the distance traveled. So from here, we are given these parameters, given that acceleration, okay, if it starts from rest, so U is equals to 0 meters per second. So anything that starts from rest, it means that acceleration, initial acceleration is 0, you understand? But accelerate uniformly until you get to this point. Okay, so final velocity, okay, sorry, final velocity is what we don't have. Okay, acceleration is 2 meters per second square, and time is 8 seconds. Okay, so these are all things we are given. So from the SUVAT equations that I generated earlier for us, we see that this formula is the one that can go for this. So we have this formula where this is here missing. Sorry, this is here. This is what we are looking for. We have A and we have T. So simply just say V is equals to 0 plus A is 2 times T is 8, right? So V is equals to 0 plus 2 times 8 is 16. So V is equals to 16 meters per second. So that's for acceleration. Okay. Now for distance, this is A. B is distance. B is distance. Now, distance traveled, we can use this other formula. S is equals to UT plus half AT squared. Where we have U, we have AT squared. Okay, so from here, S is equals to U is already 0. So whatever we have as time will be 0. Plus half times A is 2 times T is 8 then square. So this one component is already 0. So S is equals to 0 plus half. This times this. This divided by this. Understand? And I have 8 square, right? So distance is 64 because 8 times 8 is 64. So this is 64 meters. All right? So this SUVAT equation is just for us to use it properly, get the parameter that is missing. If we have every other thing except for one, that particular equation is good to go. Okay, so on the board it says a car traveling at 30 meters per second comes to rest in 5 seconds. Find its acceleration. Okay, so this is the initial velocity. U is equals to 30 meters per second. And comes to rest, V is equals to 0 meter per second. So this is the final velocity. And the time it took is 5 seconds. So we should find the acceleration. Now this one, A is equals to change in velocity over time. Final velocity is 0 minus initial velocity is 3. All over time is 5. So minus 30 over 5, because 0 minus 30 is minus 30. So this will give us minus 6 meters per second square. This minus here shows that this thing is deceleration. Okay, so the car decelerates. So the answer, I can just put a statement here. The car decelerates at 6.0 meters per second. Okay. Okay, as usual, we'll end by solving a past IGCSE question. So this question goes like this. A car moving at 20 meters per second accelerates uniformly at 2 meters per second for 10 seconds. Find its final velocity. That's the first question. Then B question says, if the car then brakes and comes to rest in 5 seconds, find its acceleration. Okay, I have a third question. Let me just add it here. Okay, so I have to adjust the question. The B, there's a B before a C. So this B says find the distance covered in this time. And finally, if the car then brakes and comes to rest in 5 seconds, find its deceleration. All right, so we dive into the questions or the answers. For the first one, the A part, where you say we should find the final velocity. Okay, so this particular formula will suffice from this SUVAT. V is equals to U plus AT. Okay. Final velocity is what we're looking for. We have, okay, let me define my parameters. I have a car moving at this. So this U is initial velocity. Yeah. Okay, so U is equals to 20 meters per second. Then acceleration A is 2 meters per second square and T is 10 seconds. All right, so we have everything. T is equals to 10 seconds. Okay, so for this first one, V is equals to U plus AT. So U is giving us 20 plus A is giving us 2 and T is giving us 10 seconds. So this one is straightforward. 2 plus 2 times 10 is 20. So V is equals to 40 meters per second. So the first one is gotten as 40 meters per second. So quickly, for the second one, I can take this off. For B, it says find the distance covered in this time. So this other formula can be used. S is equals to UT plus plus half AT square. All right. So that's why I say you should know all these formulas. Know all these formulas. Okay, so I have U, initial velocity as 20. Time is 10. Time is 10 plus half then A is 2, and time again is 10 square. All right? So this is distance covered. 20 times 10 is 200, plus this can cancel this, then 10 square is 100. So distance should be 300 meters. So this one is clear. And the final one, C part, say we should, if the car then brakes and comes to rest in 5 seconds, find the deceleration. Okay, so this one now, the change velocity, acceleration is change velocity over time. So final velocity here is given as 0. Yes, do you know why it's 0? Because it will stop if the car then brakes and comes to rest. So when you hear comes to rest or C comes to rest, you see that that velocity at that time comes to rest is 0. Final velocity is 0 minus u, which is still 20, over t. This is the t we're looking for, we are using now, 5, not this initial one, because they specify the time it finally came to rest. So 5. So 0 minus 20 is minus 20 over 5. So when you compute this quotient, you have minus 4 meter per second square. So this is the deceleration. That means the car decelerated with this value. So for this one, each formula is 1 mark, correct substitution is 1 mark, and final answer with correct unit is 1 mark. See, I'm putting unit, I'm putting my sign. So if you don't put sign here, you are not showing that it's deceleration. All right, so I hope this video has been informative for you. I'd like to thank you for viewing.